And welcome back to our 5G Summit on Federal News Network. I'm Jared Serbu. Thanks for being with us. Our guests for just a few more minutes are Dan Elmore, the Executive Director of the Wireless Security Institute at the Energy Department's Idaho National Laboratory. Tao Zhang is Manager for the Emerging Network Technologies Group at the National Institute of Standards and Technology. Jody Little, the Executive Program Manager of the 5G Next Gen program at Joint Base San Antonio, and Bob Zapataki, Senior Principal Architect for AT&T's Global Public Sector Business. And Dan, let me come back to you because Jody talked about the important role that INL is going to play here in figuring out how to change the culture of how we do wireless deployments, maybe even more broadly, network deployments. And I'm just wondering your perspective on the extent to which we're going to have to train or retrain an entire new generation to think about and implement 5G in ways that, you know, the previous generation didn't think about in 4G, 3G, even wired networks.
Yeah, right. Great question. You know, 5G is not just a step change or the next increment of from 4G. Really, it's really a game-changing, huge step change above and beyond, right? Based on what it's going to enable around the edge. Everything's software defined, and so with 4G and previous versions, network providers and that kind of managed the security, and we didn't have to think much about it. But as 5G rolls out, and it enables things like remote surgery or autonomous vehicles more broadly, right? You have to think about security from the beginning. So it's really a culture shift, right, that we're after here, where it can't just be the Verizons and AT&Ts and the manufacturers thinking about it. It has to be those mission owners that are utilizing or leveraging 5G to support some new use case right out on the edge. And that is, as Tao and others mentioned, you know, the potential threat, the vulnerability surface has gone up exponentially from what we've seen in the past. So you have to think about that early. Otherwise, it gets out of hand. You can't patch enough or add on or bolt on enough security later as this thing rolls out.
Is anyone doing this well, as far as you can tell, in terms of building the sorts of skill sets that you're going to need into the curriculum at a university, at some kind of education of higher learning? Because we're going to need a big workforce to do this, right?
Yeah, we do. It's starting, right? We've pushed it in another domain, control systems, security, industrial control systems, cybersecurity, another specialized area that has had very little attention in universities. That's growing, right? Organizations like ours and others putting a demand signal on universities, right? Because we need that talent pipeline in the United States. We need curriculum to change, right? Civil engineering programs need to be talking about cybersecurity, because why bridges are going to be electronically controlled. Electrical engineering departments, right? You can't just talk about the radios anymore. You have to talk about the software and the firmware that enable that. And 5G is a classic example. It's software defined. Network function virtualization. Many of the security features we touched on, right? They're software controlled, software enabled or disabled, all open for potential exploitation. So we need to think differently.
So one of the things we've seen is that people don't understand 5G, especially the SA side, enough. They still equate it to what they've done in 4G. Plug it in, let it be secure behind the firewall, and it's going to be completely different. And we're seeing that. I think we're seeing that quite a bit on the education side. It just hasn't reached them to train the trainers even. Right. We're still at that point. I agree with you 100%. The one thing I do want to add, though, is on the federal and the national 5G strategy, and in the DoD 5G strategy and the DoD 5G implementation strategy, they all require this level of security and this level of analysis to get there. These studies we're doing and to build that base. And so one of the things the OSD's, one of the purposes was to try to build the industrial base that can get us there, but it can't do it alone.
No, it can't. And it's encouraging to see the security component woven through those documents, you know, the national level documents, the executive orders, et cetera. You get that leadership backing. Now the devil's in the details, though, right? How do you make that happen? That's where a lot of the challenges are and will be for the next several years.
And I haven't seen, I see a lot of 5G, but I haven't seen a teaching 5G or education of 5G architecture or education of 5G cyber consortium webinars, things going on.
Yeah.
And I think that needs to start now.
There's a couple of them out there. Nokia has a pretty good course on 5G fundamentals and basics, as does Qualcomm. But again,
Yes.
it may be tailored and tuned to a specific set of audience.
Your workshop was one of the first ones that I thought that sort of leaned toward that. It really wasn't education focused, but it had that message coming out of it.
Yeah, we're trying to fill what we see as a gap with that, Jody. We've done a couple workshops now. We got another one probably in June, really with the 5G security focus, bringing academia, government, industry together to talk about where are the gaps, where's the challenges going forward, where do we need to apply resources a little bit differently, right, across these areas.
I just want to add that I also observed, I work with universities quite a lot around the world. And I also observed that education of 5G is done much, much more broadly in elsewhere, especially, for example, in Asia. And you see them much more broadly integrated into the teaching. You see better tools there, and also in parts of Europe. So, for example, in Asia, you see sort of the universities participating in developing open source 5G implementations years ago, while the 5G standards were still being developed. So they developed their tools along with the standard, and they integrated into the teaching of the classes. So I see much less of that here in the US.
I want to shift gears just a little bit here and talk about why all of these wicked problems are worth solving, and talk a bit about some of the use cases for 5G. And Bob, let me come to you on this. When federal agency customers talk to you, what possibilities do they see, or what possibilities do you see for them that maybe they're not thinking about yet?
Well, I mean, there's a lot of things that 5G can bring to the forefront, and Jody and everybody else has kind of talked quite a bit about some of the things that have been looked at by OUSD in the tranche 1, tranche 1.5, tranche 2 that they're coming up with. But I think it's important to understand that the promise of what 5G brings to the table is a capability to have massive connectivity, a capability to have much lower latency in data transactions, and a capability for larger throughputs for those transactions as well. So when you think of the kinds of things that really, at least in my mind, kind of are driven by those types of use cases, you're really looking at areas that are really built around things like automated vehicle guidance systems. And we talked a little bit about that earlier. Platforms that use augmented reality and virtual reality, things like training, for instance. In fact, a lot of studies that have been done using an augmented or virtual reality enhanced training methodology have actually shown that the effectiveness of that training can increase by as much as 76%. So you're talking about a significant increase in the ability for a learner to retain that information. When you bring in AR and VR as well, you've got this instant expert kind of model that you can put into place where you have the capability in the field to deliver a set of services. Let's say it might be maintenance, could be maintenance of robotics, for instance, that kind of thing. But then you've got the ability to call in an additional resource that can help you through whatever it is that you're running into. And that's what I would call on-the-job training on steroids. The other thing that's important is artificial intelligence, machine learning, taking those capabilities, bringing them to kind of a robotics and response system environment. All of those are really facilitated. Any use cases that include those areas are really facilitated by the use of 5G and the capabilities around edge compute and high data throughput that are supported in the environment.
I mean, obviously a lot of exciting possibilities, but I think it brings us back to the question of, to what extent does everything Bob just talked about get enabled by just the fact of bigger data pipes? And to what extent do you actually need to sprinkle on the fairy dust that Tao talked about toward the beginning of the conversation, which is the parts of the standards that allow you to do differentiation and optimization?
Mm-hmm. I know other folks are going to chime in, but just the fact that you have fat pipes doesn't necessarily mean that you're going to have a much better performing environment. All of the things that really, in fact, I would argue that latency may actually be as important, if not better, than the amount of data throughput that you can bring to the table, because that's really what's going to facilitate these sort of near real-time transactions that are required to support and the differentiation that was talked about to be able to support those kinds of applications.
Yeah, and ultra reliable low latencies is way behind the slicing to begin with in 5G. So that's still emerging. We've been looking at that. On the telemed side, you talked about the training. We've got actually a couple training use cases we're looking at. One is to train the mobile medics pre-deployment. So they have to bring either the trainer to the medics or the medics to the training. With 5G, we can put it out using AR, VR models and simulation and do them. And we're well aware of the increase in potential training capability, as well as how fast we can train the medics to get, because the medical procedures are always refresh or new procedures. We're also working with pilot training transition, doing pilot training before they ever touch the aircraft. They get full understanding of the aircraft cockpit, aircraft capabilities, as well as emergency procedures, which is critical to the pilot. So we're working with the Air Force on that side as well. Both of those require ultra low latency and volumes of data pushed forward into that edge to support that. So it's become critical in those. When you get into the IoT side of it, where you have thousands of sensors going, and one of the use cases we had is if you're out in a forward area with lots of patients, you only have so many medics or nurses that can take care of those patients. And we've seen this with COVID. But if I can have the right sensors on there and collecting all that data in real time, I can monitor those patients and make more effective use of my medical core to support them. So there's various use cases. But I agree with you, not everything's going to take advantage of 5G until 5G is the base standard. Because we've looked at use cases where we've had proposed use cases where 4G will certainly do it well right now. So why go to 5G without that additional application increase you're going to get out of having 5G?
But at some point,
so we
have to go to 5G, right? Because that's what it's coming, whether we want it or not in all cases. So we've got to start getting our arms around it, which is the point of the pilot. The DoD pilot efforts like you're leading down there, Jody, which is fantastic, and other sectors too. I mean, we have to get our head around it because
it's going to be pervasive, Dan. You're right, and all the security we've talked about and all these issues we've brought up today, they're coming fast, and we're at the moment not prepared. But with INL, with Tao's work, with Robert's work, we're working hard to spin up very quick. And for example, the programs that we're running with OUSD, R&E, are application specific. I mean, they're looking at prototypes so that we can get things up and running towards transition very fast and build that base, as opposed to just researching it, if you will. But that has to go in hand with, say, things INL and others are doing on the background, looking at the dynamic spectrum usage, looking at how things work actually in the range as opposed to in the lab.
Right. Well, that's why DoD has funded quite a bit of our range effort, and they're funding a big chunk of our 5G build out, right, to support what the national strategy calls for, right? We need to roll this out securely, but we need places to test and validate at scale, and so we're definitely one of those places, and working with Jody and others going forward on that.
Bob, it sounded like you were trying to get in there. You want to get the last word before we have to close out?
Well, what I was going to say is that, all of the things that we're talking about are, moving towards 5G. It's going to happen. I mean, and one of the benefits of what was done to move between 4G and 5G is this capability to allow for a mixing of spectrum, let's say, right? The ability to allow for what is called dynamic spectrum sharing from a 3GPP perspective, that brings together both 5G and 4G and allows for a provider like AT&T or a user to actually leverage that device within the network, and that same spectrum can be used across the board, whether it's a 4G interface or whether it's a 5G interface. In the long run, that's very beneficial because, in all honesty, this is the fastest that I have ever seen an uptake of a new technology for field deployment in my 22 years in the business. So with that, the standards have actually allowed for a better transition model than before, when you'd have to kind of go in and say, thou shalt carve off this much spectrum to support the new technology.
Plenty more to talk about. I think, as I predicted toward the beginning, we just scratched the surface on a lot of these issues, but it's been an absolutely fascinating discussion, which we unfortunately have to leave there for because of time constraints. I do want to thank today's guest. Dan Elmore is the Executive Director of the Wireless Security Institute at the Energy Department's Idaho National Laboratory. Tao Zhang, Manager of the Emerging Network Technologies Group at the National Institute of Standards and Technology. Jody Little, the Executive Program Manager of the 5G Next Gen program at Joint Base San Antonio. And Bob Zapataki, Senior Principal Architect for AT&T's Global Public Sector Business. All of you, thanks again for doing this. I really appreciate you taking the time. It was a great discussion. I'm your moderator, Jared Serbu, and you're listening to Federal News Network. For more on this discussion, visit federalnewsnetwork.com and search AT&T.